Today we have a integral based on a binary function called the min function. Now, I never had thought about doing an integral, a definite integral or something like this, but let's just review briefly, intuitively, what the min function does. Like, say if you, it's a binary operator, so if you take the min of, say, let's say, I don't know, whatever, 9, 4, these are the two input arguments. Intuitively, the min here is equal to 4, and that's exactly what it means. It's a very, very simple operator that's easy to do by inspection, normally if you have numbers. But here we're actually making it a function of x. We have the 8th root of 17 combined with the square root of x, and we want to find out what the integral of this is, and this is a function. So it's a legitimate question. Okay, now let's take a look and see how we might proceed here. The first thing, probably the easiest approach, is to find out if there's a break point in here where we can split the integral. Now notice that you can rewrite the square root of x as x raised to the 1/2 power, just shifting to rational exponents. And you can write the 8th root of 17 as 17 to the 1/8, right? So it's very clear that when you square these numbers, you get this statement over here that x is greater than or equal to the 4th root of 17. Now notice that the 4th root of 17 is definitely trapped between 1 and 4. Okay, so let's write that down just as a note here. Okay, and again, that's fairly easy to see since we know that the 4th root of 16 is just equal to 2, right? 4th root of 16 is equal to 2, since 2 times 2 times 2 times 2, 4 times is 16. Okay, so 4th root of 16 is equal to 2. The 4th root of 17 would be a slightly bigger number, right? But it's still going to be between 1 and 4, okay? Now, so let's move along here. This statement here has the nice implication that the square root of x is less than, I guess we can say less than or equal to. It's less than or equal to the 8th root of 17. Whenever x is between 1 and the 8th root of 17. Or let's see here, wait, less than, x in the 8th root of 17. Let me write it like that. Sorry, this would be the 4th root of 17, my bad. Right, folks? Okay. So that means this is actually smaller than the 8th root of 17 when x is trapped between these two numbers. And that gives us motivation for the following statement. We can split the integral. Since root x is the smaller of the two values between 1 and 4th root of 17, we split the integrals accordingly. All right, and then it switches, you see. 8 of 17 is the smaller value when x is between the 4th root of 17 and 4, right? And so we just split the integrals, and the rest of it's just fairly routine. Remember that the antiderivative of the square root of x is just equal to, it's slightly easier to write this, I guess, in, we'll write it like this. If you want to, we can write it as x to the 3/2 over 3/2. Now it's not equals. I should divide it by 3/2. Okay, this isn't an equal sign. That should just be an arrow. So let me just put an arrow here, and then we just mean antiderivative, right? So that's the antiderivative. Let me put AD right here. Not after the death, but antiderivative. Okay, now notice that dividing by 3/2 is equivalent to multiplying through by 2/3. Okay, and anyway, I just left it in this form, folks. This is applying the antiderivative and evaluating at both endpoints. Notice when you substitute 1 into right here, this is where this 1 comes from. This 1 evaluated at this mass is just 1, right? Okay, and the rest of it is just this is just a constant, and so it's the area here is just the magnitude of the constant times the difference between the limits of integration, right? And y'all, I think this comes out to circa 4.07. It's not particularly important really. It's just the idea behind how you solve the problem. I thought that was interesting. But anyway, this is the answer to the question right here, just this expression, and then here's your decimal approximation. And really the only part that was marginally challenging was just to convert this inequality into something that was useful in terms of determining how to split the integrals. And it's easy to get this backwards in your mind. I originally wrote down root x here and then root 817 right here, and I realized no, this is the correct approach right here. But anyway, there you go. Just a little bit of reasoning and some fairly straightforward calculus.